Hey guys, Anthony here with Advanced Vector, and today again we're bringing you something different. So a while back, several months ago, I did a high performance streaming slash rendering PC with a server motherboard, and as I mentioned there, I always wanted this channel to be more than just video games, and so I decided to start down that path today. So to do that, I've been learning and watching and studying a ton about small electronics. And so I bought a bunch of kits that will hopefully be the basis for my new electronics lab. So what I got here is I ordered this from Banggood, and it's a component tester. I'll show you the page on Banggood in just a second. But yeah, I'm pretty excited about this. I haven't really taken it out of the box. I have watched some videos and stuff, but for the most part, this stuff is pretty simple. In the past, I have had a bit of experience with, small electronics. I've done some very light Arduino type projects and other things like that, but I'm really hoping that I can really expand my knowledge of how all this stuff works and what the different things are. In the past, I've mostly just done some very simple tutorials online with some Raspberry Pis and other stuff, and so yeah, I'm really looking forward to learning. Please leave comments below if you see me make mistakes or whatnot. I will be the first to admit right now that I definitely don't 100% know what I'm doing. Most of the time, I'm just going to be Googling, maybe watching some other videos on how to figure some of this stuff out, and of course I will always provide links to any videos that I use to bring you guys content. So first off, I kind of just want to look at this board a little bit, see if I can get my camera to focus here. Maybe. Oh, there we go. So it's pretty cool with these kits. I think they're very user friendly. I mean, it tells you exactly where everything goes. As we can see here, there's a notch right there, so we know which way our ATmega 328 P chip goes. Everything's labeled. It's extremely just user friendly. So as I said, this is a transistor tester, but I think it does more than just transistors. It's actually a pretty generic component tester from what I understand, and I figured that this would be extremely useful as we do some more builds. I do have a few more kits, so I'm hoping to do a couple of these videos over the next few weeks. So anyways, let's cut out and we'll take a look at what this looks like on Banggood. Alright guys, so here we are. Here's the listing for what I got on Banggood, and I actually did order this from the Chinese warehouse, and I think I even got it on sale, but still at $11.59. That's not a bad deal. I want to say it showed up to me in the US here in about 10 days. The package was it just came in one of those kind of plastic wrap bags, the poly mailer bags, and yep. So we can see working power supply voltage is 5.5 to 12 volts. Working current is 24 milliamps at 9 volts, and then we got some size. So I don't know exactly all the details, but I just figure I'd get it. A lot of people had some really good reviews about it. Here's the unit completely put together. So it should be a pretty fun thing. So I'm gonna go ahead and get everything kind of sorted, and then go into the build just a little bit. Alright guys, as you can see, I kind of got the main pieces laid out here. So really, there's not anything super crazy here. We've got the LCD, we have our ATmega 328, some kind of like a little clamp box thing. I'm assuming that's where we put the ends of the stuff. This like little button, some standoffs. capacitors, resistors, some things that I'm not really sure what they are. I can't remember. Um, it's just the title to my noobishness. This, I believe, is a frequency crystal, probably, what is it, 16 megahertz that you have to run the chip. And then we got the board. So I'm definitely going to have to bring up a guide for these resistors. I know that the little bands, you know, the different colors and what order they're in, indicate, you know, how much resistance they provide, I guess, if that's the right way to say that. But I have no idea exactly which ones are which is part of why I'm building this tester first. You know, hopefully eventually, as I get into this more and learn more, it will be something that I can kind of just start to recognize at least the common ones. But in the beginning, it'll be good to check. So anyways, guys, I'm going to do a little research. I'm going to start putting this thing together. And, you know, if I come across anything or, I don't know, just feel like talking a little more, I'll bring you guys back in and we'll go from that point. Alright, guys, so I was doing this first one. And, you know, I'm kind of looking at the board for a reference. And this first one that I grabbed, if we can see the multimeter over here, if I stick that on here, so 32.88 kiloohms, I think. I don't know. I need to I need to get my my nomenclature right. I'm sure someone in the comments will correct me, and I appreciate that as I am trying to learn. So from this board, oh, so I think that must be 33K. If I look at my chart, I think the lines match up with that. So if I can get this to focus, there we go. So this 33 is the only one of its kind, and so I'm guessing it definitely goes in that spot right there. So what's interesting to me is, what is this 3K3? I see I have two of those, and then I also have down here on the other side 2K2. So definitely going to have to do some research. This is all really cool, really interesting stuff. I'm super excited to be learning this. So anyways, I kind of thought I would just bring that up. You know, if we look at, again, if I can get it to focus. Come on, baby. There it is. You know, so if you look at this, I can see, you know, and it's hard to say which side you're supposed to start with. You know, actually, so it might be this way, which means we need to do, come on, baby, come back into focus for me. Anyways, there it is. So orange, orange, black. If I look at that on the table, I think that's 330, which would maybe be the 33 or 330. Well, no, it would be 1,000 if we're doing kilo. I don't know. I'll have to do some more research, but it's all interesting stuff. I thought I would just kind of bring that up, that, you know, I do have my multimeter here that I am using to kind of like figure all this stuff out. So again, if you have like any helpful tips or tricks in the comment for, I don't know, maybe remembering the colors or anything like that, definitely place that down there. I would super appreciate it. Alright, guys, so I was doing a little bit more research into what the K means, and apparently it's just a kind of shorthand to help save space. So if we look at this answer here by variance, it just says it's to shorten the length of the values of resistors or capacitors. In schematics, the decimal separator is often replaced by the metric prefix, and the unit is omitted completely, as is defined by the type of device. So 2200 ohm would be 2.2 kilo ohm or 2K2. So that's super cool. That's really good to know. That'll definitely be helpful as I continue to get all of these resistors in place. Alright, there it is. I'm pretty sure that is all of the resistors there on our lovely board. Focus, focus. There we go. So cool. I'm now going to flip those over. We'll get those soldered in position and move on to the next components. Well, we finally got them all on there. Certainly not the best I've ever done. As we can see some of them here kind of focus. Got a little bit wonky. But it works. It works. I'm overall pretty pleased with it. I'm not super experienced with soldering, so anyways, I'm going to move on to the next components here, and we'll keep going. All right, now I got some of the capacitors on, and then these little black things. I'm not sure exactly what they are, so I'm going to look into it and find out. Alright guys, and we're back. So I had to run out to the store, grab a couple of these 9-volt batteries. I actually think I'm going to pick up some rechargeables. I just, now that I'm getting into this stuff, I find that my need for batteries is a little bit higher than I've had in the past. So anyways, we'll get one of these 9-volt batteries on here. And we'll see what this sucker can do. Okay, cool. It sees the battery. So we don't have a part in there right now. Now, if I remember correctly, okay, yeah, so clamp the 3 pins together. Okay, so let's see if I can do that. So let's open up our gate here. And if I remember correctly, so we have pins 1 and 2 here. I think 2 and 3 there. Let me just make one more little jumper here. And actually, I think maybe this one needs to go in between them. Oops, my tweezers here are slightly magnetized. Alright, so let's see if that's correct. We'll turn that on. Self-test mode, question mark. Okay, perfect. So I think that, I do believe that does mean that we are in test mode. So to get to the selection menu, we just kind of hold down this button thing here. We can see there's a switch off, show data, contrast, self-test, rotary encoder, not sure what that is. I'm not sure what that is. 10-bit PWM, power, interesting. F generator, frequency, transistor, kind of back around. All right, so let's go ahead and run this self-test. So it looks like it's going through just a bunch of different tests here. Overall, I'm really pleased with this. I have to say, as the first kind of kit type thing that I've built in a long time, this was super fun. You know, really easy, really well labeled. I'm glad that I'm kind of jumping into these very user-friendly, noob-friendly kits. Definitely looking forward to some of the projects I have in mind down the road that are certainly going to be more custom, but this is definitely a good way to jump into the waters, and it also gives you a couple of really neat tools that you can end up using for you know, your workshop, for completing those more advanced kind of custom projects that we come across. So I wonder if it's hung here. See, I don't really see. We'll just let it run. We'll let it run. Alright guys, so it's been on this for a while. I was doing a little reading online at the manual, and apparently isolate probe, it means that it's time to separate the probes. So I'm going to release my little jumpers there, and then I need to get a capacitor between 100 NF or 20 UF connected between them. So let's go ahead and see if I have such a capacitor handy. You know, this is the capacitor that came with it, so I'm going to go ahead and put this in here, and I don't know how big this one is. I'm pretty sure there's a way to measure capacitance with my multimeter, but I'd have to investigate that. But I'm going to go ahead and say the reason that they gave us this big ugly looking one is for the test. So let me go ahead and release these probes, and then I need to put it between pin 1 and 3. So let me get these out of here. And pin 1 and pin 3, I think. And we'll stick it in there. Oh, actually, I think I did that wrong. I gotta wait till it prompts me to put that in there. So excuse me, let's do that again. Alright, here's where it's asking us for this. So we're gonna go between pin 1 and 3. Alright, and it looks like our self-test is good. We should be good to go. So let me pull that out. And I've already got my multimeter here ready to measure these. So let's take a look and see if we can get these resistors. Alright, so my multimeter is reading this at 0.99 kiloohms, I guess. So basically 1K. So I think we can stick this in between pretty much any of the pins, and it should work. So let's, oh, I don't want to self-test. So let's restart it. You know, I wonder if you have to recalibrate it every time you disconnect the power. .994 or 994.1. That's pretty close. That is pretty dang close. Let's look at that on the multimeter one more time. And the multimeter here is reading 0.993. This is 994, so that was, they're really close. So that's pretty cool that that's that accurate. Let's try another one. So this is reading 103.4 kilos. We'll stick this one inside of our tester here. Oh, 103. And then one more time here. I wish my multimeter kind of kept a short record. 103. Wow, that's really close. All right, so this tester seemed to be fairly accurate. Now I don't have too many other parts here. As you can see, I have a few more resistors, but we've kind of tested those. So the only other thing I have is just this capacitor for now. I mean, I have a few other kits, but I'm not going to go tearing into those just for this. So alright, that shows up as a capacitor with 222 nanofarads, I think is how they say, or yeah, whatever it is. I'll have to Google that. NF. So cool. Well, guys, I gotta say this tester has ended up being pretty cool. It was a really neat project to work on, and I mean, I definitely feel like I'm going to be using this all the time. It's cool, it's simple, it's easy, it's small. You know, I obviously I have my multimeter here that I could utilize, but it's just so big and bulky. Plus, you know, I've got the alligator ends on it, and it's just a lot. You know, it's neat that I can kind of just prop this up here as I'm doing something, and check my my resistors, capacitors, and other stuff to make sure I'm using the right parts. So anyways, thanks for watching, guys. If you liked the video, definitely hit that thumbs up button. If you haven't already, please subscribe. I appreciate all of my supporters out there. I'm going to be trying to bring you more of these cool electronics videos as we learn. I do appreciate the feedback, guys. You know, let's keep it somewhat positive. Feedback, as I am still learning, but criticism, anything of that's, you know, of the constructive nature is greatly appreciated. You know, I know that there's people out there that are way more knowledgeable when it comes to this stuff, and if you guys want to give me some tips, tricks, pointers, it is greatly appreciated. So with that, I guess until we see you next time, have a good one.